Hi guys, here we are again, trying to find the limits. Today we are going to use two methods. Mostly we are going to work with rationalization, and then I will show you a little bit of a tricks to how to find limits. So if we look at this first example again, when you are looking for a limit at a point, the first thing you want to do is you want to plug in that point and see what happens. So 3 squared is going to give you 9. 9 minus 9 is 0. Square root of 3 is just square root of 3 minus square root of 3 is 0. And again, this is problematic. This is something that calls for caution, and we need to take this expression and try to write it in a different form. So because we see the radicals, what we can try is we can try to multiply by a conjugate. So we will multiply by the conjugate of square root of x minus square root of 3, and then we can hope for the best. So x squared minus 9 divided by square root of x minus square root of 3. And what I am going to do is I'm going to put those guys in parentheses, and I am going to multiply by exactly the same thing that I have here. The only thing that I'm going to change is I'm going to change the sign so that that is forming the conjugate. Again, when we are expanding, we need to make sure that we don't multiply by anything other than 1. And in order to make this 1, I am going to put exactly the same thing on the top of the fraction. All right, so notice again, I took my original expression, I am multiplying it by 1 in a form that looks like this, so that I have this conjugate expression, which is going to give me something interesting and helpful. When you multiply conjugates, this is the beauty of this, is that you have a difference of squares. So we are going to multiply the first term, and we are going to multiply the second term, and we are going to put negative sign between them. This thing, well, I do not want to distribute because I want to keep it as factors so that hopefully something simplifies. X squared minus 9 is also a difference of squares. So I'm going to write this down as x minus 3x plus 3. And then I still have the square root of x plus square root of 3. Look how convenient. This and this cancels out. I'm going to take my time and I'm going to write what I have at this moment. Limit as x goes to 3 of x plus 3 times square root of x plus square root of 3. And now if you plug in 3 everywhere in place of x, we will get 3 plus 3, that's 6. Square root of 3 plus square root of 3. And this is going to give me 2 square root of 3's. So I have 6 times 2 square root of 3, which is going to give me 12 square root of 3. So the limit of this very, very messy expression that I started with is equivalent to 12 square root of 3. If you do have a graphing calculator, graph a graph of something that looks like this and take a look at what is happening at x is equal to 3. All right, let's look at another one, and this one is interesting because usually what we do is we rationalize the denominators like we did in the first example, but in this case the radical is in the numerator, and for the purpose of limits we are going to rationalize the numerator. So, well, we will if we need to. So let's see if we do. 7 plus 2, that's 9. Square root of 9 is 3. 3 minus 3 is 0. 7 minus 7 is 0. Yes, we do get the problematic term of 0 over 0. So we do need to do some magic. All right, so I have square root of x plus 2 minus 3, x minus 7. And now I am going to put everything into parentheses, and I'm going to multiply by the conjugate, and I'm going to hope for the best. So the conjugate, the first term is the same, the second term is the same, but the sign is opposite. And then whatever I put on the top, so whatever my conjugate is, I need to have it on the bottom as well. The reason for it is, again, because we are actually multiplying the given expression by 1, so we are not changing the value of it. Limit as x goes towards 7. Let's see what happens. Well, the conjugate, so again, this is giving me a difference of squares, so I will have x plus 2 minus 9 over, and I am not going to multiply it out. Again, remember, what you do want is you do want to simplify, so you don't want to make your life more difficult. Well, this plus should be after the radical. Well, I have this magic thing, so we can make it nice. 2 minus 9 is 7, negative. So I will have x minus 7 times this mass. How convenient. Remember, this is giving you 1. So the limit is 1 over 7 plus 2 is 9. Square root of 9 is 3. 3 plus 3 is 6. So the limit is equivalent to 1/6. All right, I think we did an example like this yesterday. At first, when you look at something like this, it may look weird. But the second thing is, well, we are not going to use rationalization. That's something you'll practice for homework. But, well, let's see the first thing. What happens when we plug in 0? 2 plus 0 is 2. 2 to the power of negative 1 is 1/2. Minus 1/2 over 0. 0 over 0, there's our problem. What can we do about this? Limit as x goes towards 0. Let's write this as fractions. Let's write this as fractions, and that is going to bring us to something as we did yesterday. And I'm trying to think, I hope we didn't do the same example, but if we did, that's okay. So instead of writing this using negative exponents, I rewrote it using fractions. And again, that's something just to review of what we did yesterday. Common denominator. Well, it looks really familiar, this example. 2 plus x. Let's not forget about the limit. 2 plus x times 2 is going to be my common denominator. 2 minus 2 minus x. And then divided by x, I am going to multiply by 1 over x. 2 minus 2 is 0. So I am going to have limit as x goes to 0. This will simplify, so I only have negative 1 on the top of the fraction, and on the bottom of the fraction I have 4 plus 2x. If I plug in 0, this is 0, negative 1/4. I think I used the same example I did yesterday, but that's okay. Alright guys, and a little bit of magic with trig. So let's start writing here. There are 2 definitions that we are going to use. And notice how I am skipping the one that I am not putting into this, whatever this is. So if you have a limit and you want your angle to go towards 0, and if you can write your expression as sine of the angle, or whatever variable you are using as long as they are matching, over the same value that the angle is, then that is equivalent to 1. Okay, so this is something that we are going to remember, that we are going to use in a second. Now, the same thing works if we switch. So if you put the angle on the top and the sine of theta of that angle on the bottom. As long as the angle is going towards 0, this is also going to be equivalent to 1. The one that I put right here that I did not include into this beautiful, whatever that is the limit as a data goes to infinity. the limit of that expression would be equivalent to 0. And again, this is something that we would have to explain a little bit farther. For now, we are going to take this as a definition. Having said that, let's try to find the limit of, as x goes to 0, of sine of 2x over 2x. So notice how this is almost like that, but we have 2x and we have only x right here. So now the question is, can we make it to be 2x? Well, watch this. I am going to expand this. So I am going to multiply it by 2, but I can't just multiply by 2. It's the same thing as when we rationalized. When you multiply numerator or denominator by something, you need to multiply the other one by the same thing. So notice if I multiply this by 2 over 1, what I did is I actually multiplied the expression that was given by 1, but I made it work for me. So having said that, this is equivalent to 1, because as long as the angles are the same and we made them the same, the expression is equivalent to 1. So this is 1, and then you will multiply it by 2. Here we go. You just found the first limit that involves the trig. Of course, that can get a little bit more difficult than that, and I did include some more difficult examples on your assignment. And by doing this, I hope that I will see more of you tomorrow during our study time. So I will look forward to seeing many of you. But let's take a look at this one. So another one that involves the limit, and this has 2x, this has 4x. Well, it's always difficult to play with the angles with trig. So what I am going to do is I am going to leave this alone. But now I want to make sure that this is 2x. So then I know that this is equivalent to 1. But in order for this to be equivalent, I need to multiply my expression by 2. 2 times 2x would be 4x. So notice I didn't change anything. I didn't multiply anything by anything new, but I split the 4x into 2x times 2. Now from here, I know that this is equivalent to 1, and 1 times 1/2 is going to give me 1/2. There are different methods on how to solve examples like this. You know that sine of 2x is sine of 2 sine of x cosine of x. So you could play with that as well, but this is a very common way, and this is a good one. All right, as I said, there's going to be a good amount of assignment problems, and come see me if you have any questions, especially with the ones that I will assign that will involve trig. And again, make sure you have fun with that.